I hope that the sound will work. Okay. 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 We have to start. Okay. Good notes, right? This one. Yeah. In this semester, we the sound test 1, 2, 3. Low test 1, 2, 3 ครับI got no. Test 1, 2, 3. Low test 1, 2, 3. เหมือนว่าเสียงไม่ออกครับ Okay. Test 1, 2, 3. Low test 1, 2, 3. Low 1, 2, 3 ครับ Low test 1, 2, 3. เสียงไปไหมครับ Low test. Okay. Yes. Let's continue our บอกด้วยนะครับถ้าเสียงไปไม่ไปนะครับผมเช็คแล้วไม่มีเสียงไปนะครับ Alright. Yeah. We will start our lecture in this semester. So welcome you to SCI. Actually, it should be SCI33206 physics number 5, but I don't understand why it is written here number 4. It's wrong. Okay, I will change it later. So we will talk about the solid and liquid in this semester, right? In yes, the content เสียงไปไหมครับเสียงไปนะมิเตอร์มีพิมพ์ชื่อมาครับ I hope that you can hear well, right? Yeah, the content in this chapter is the following. Okay, the content in this chapter is as follow. First, we will. That's only the first. That's only the single title that we are gonna talk about the solid. Okay, that chapter is about solid and liquid, right? I didn't tell you that in this semester we will have a lot of thing to see. The 5th chapter. Where is my mouse? Now my man. The 5th chapter is solid and liquid, and in the 6th chapter it is atomic physics, right? Atomic physics. And the 7th chapter is nuclear physics and particle physics. Okay, the particle physics is quite new. I didn't heard about that during my age in high school or secondary school. Okay, so the first chapter to this semester is solid and fluids, and the section that we are gonna consider solid is only this one, the first section, right? It's elastic behavior of solid. So we will talk about stress and strain, okay, in several aspects. For example, in the longitudinal aspect, so we will talk about the length of that object, okay, the length of the solid material. Yes, and the next thing is the shear, okay, shear behavior of that solid. And if you are interested in studying mechanical engineering, so this chapter is quite important to you, okay, apart from thermodynamics, okay, because several stuff in mechanical engineering has something to do with this, okay, and you in bachelor degree you're gonna deal with the subject which is called statics, okay, not statistics. Statistic is mathematics, okay. Static is something about something that stay idle, okay, stay constant. And another subject in bachelor degree is dynamic, okay. If you are interested in industrial engineering or IE or mechanical engineering, okay, you have to deal with the whole stuff here together with thermodynamics, which should be in the previous semester. And in the second section, the third section, the remaining actually, okay, the second, the third, and the fourth section in this chapter will be something about liquid only, okay. Liquid means gas and liquid, okay. As you know, there are mainly three phases of the substance, right? The solid one, right? This one, the solid, and the next one is liquid phase, and the next one is gas phase, right? And apart from these three main fundamental states, we have the so-called plasma, right? And even higher than plasma, we have ion, right? Okay, but in this chapter, we will talk about only three phases: the solid and liquid and gas, okay, which are combined into the word called liquid, okay. And yeah, fluid is something about liquid and gas, right? And in the second section, we will talk about the surface tension of the liquid, okay, in viscosity too, right? Viscosity is mainly related to the behavior of oil and so on that is used in automotive industry. Fluid statics is something about fluid pressure. We will talk about fluid pressure, buoyant force, right? The force that is discovered by Archimedes. Fluid dynamics, here the fluid stay constant, right? In this section, the last section will be movement of the fluid, and we will see we will introduce this section with ideal fluid, the continuity equation, and Bernoulli's equation. Yeah. This one is more general, right? And yeah, that's the whole thing in this chapter. And let's start with the first topic, right? First section, elastic behavior of solid. We will อาจารย์ครับขอรหัสเข้า Zoom อินนกได้ครับล็อกอินno, yeah. Anyone else? Two people, right? Two people in this right? ณภัทรนัทพัฒน์นะครับแล้วก็พิเชษพงศ์ปัญญะ604ไม่ได้มีใครลาออกนะก็ไม่มีปัญหาแล้ว605มีลาออกหลังจากหมายเลข16ขอให้ลดลงไปนะครับเพื่อว่าจะได้ง่ายต่อผมนะครับในการจัดการนะครับ yeah but there is no problem at all to M604 right okay the first aspect in elastic behavior of solid is the longitudinal behavior, right? If you okay, let's introduce first two main words, right? If you want a good person in material science, okay, you need to know two words, right? I have also some classmates or colleagues from mechanical engineering. So their two basic words are stress and strain. Okay, stress is the force per unit area, right? It's like a pressure that you have seen in gas and so on. But this one is like something we have to we would like to destroy a solid object, right? Force per unit that causes a deformation of that shape of the solid, right? And the second thing is second term is strain, right? It's some kind of measure to the amount of deformation. Okay, so the shape of that solid has transformed, has been changed. Okay, let's take a look at this. If you hold this device, okay, onto the plane of the table, okay, it's fixed, and this is the device. Okay, if you rotate it, it's gonna keep this one fixed to the surface of the table. And okay, you start with this one. Okay, and if you try to pull or stretch this one out by the external force, which is denoted by the variable f, okay, with the arrow on top, right? It's vector representation. Okay, the bar is stretched by you put the force, and of course, if you take a look at the physical thing, you will see that this metal is gonna be stretched. Okay, its length is gonna be larger. Okay, by the amount of delta L. For example, if you have the length starting at the beginning like this, okay, L0, and if you put the force, you find that the length of this object increases, okay, by the amount of delta L. Okay, and let's say that the cross-sectional area of this cubic shape of this metal or this steel is variable A. Okay, and yeah, we will observe two terms, right? Stress, which is the ratio between the magnitude of the force per the area A, and strain is the ratio between the original the stretched length, okay, delta L divided by L0, the initial length. Okay, รับผมเข้าซูมหน่อยครับ Oh, I'm sorry for that. Anyone else? Okay, Shayasit, sorry for that. อะไร605น่าจะลา Okay, let's get back to our stop here. And yeah, right, two terms, two quantities that are important to us. The word, you may also hear this word, right? Tensile. Okay, if you go further in mechanical engineering, has the same root as the word tension. Okay, and it's came from Latin word and so on, right? And it's used because the bar is under tension. We define the tensile stress as the ratio of the magnitude of the external force F, right? F vector, but we say it's F. Okay, without vector, that's the magnitude to the cross-sectional area A. Okay, cross-sectional area A here, and the absolute value of this one is the magnitude, right? Which is denoted by the plane F. Okay, without any arrow on top. Well, let's talk, because we are in physics, right? So we have to talk about the unit, and the most common unit that we use, okay, that is formally used is the SI system, right? System International, right? Yeah. Because F has the unit of the Newton, and the area is square meter, right? It's going to be Newton per square meter. That's the word in SI system, right? But we usually use a shorter name, which is or in the honor of Pascal, right? We're gonna say Pascal, and we use the abbreviation PA, right? Capital P and small a, right? It's the same as the pressure for the gas, right? So simply speaking, stress is a stress has the same unit as the pressure, and we would say tensile stress, okay, stress, because it's under the extension or the tension, right? In the longitudinal dimension. We will have two aspects later, right? It's in shear movement and the bulk movement, which is the volume reduction. Okay, we will talk about that later. But in several books, they have provided the value of state strain or Young modulus for those three kinds of straight strain. Okay. After we discuss the unit of the straits, right, we will see the next thing, which is the tensile strain. Okay, tensile means extension or something like that, longitudinal dimension, and strain, right? It's the ratio between extended length, okay, the change in length, okay, delta L, okay, in divided by the original length L0, right? Let's have to split screen to that so that you can see new this one. Okay. Yeah. Here, this one. All right. Yeah. The epsilon, right? They use the Greek alphabet. Epsilon comes from the word error. Okay. Similarly, similar to error in English, they use the Greek letter E. Okay. And yeah, epsilon is the ratio between delta L by L0, the original length, right? The initial length. And you can see that this ratio has the same thing, right? Similar thing, right? The unit of delta L is, let's say in SI system, we say meter, right? And the length, or the unit of L0 is also meter. So meter by meter is gonna vanish, right? There will be no unit at all for this ratio, and therefore we would have no dimension for the tensile strain. Okay, this one has no unit. Okay, we have discussed about the stress. Okay, sigma is F by A. Okay, it's similar to pressure, right? And the next thing is the strain, right? Epsilon delta L by L0. The third, before we go to the third quantity, let's take a look at the real measurement that some scientists or engineers have found, okay, in nature. For example, stress versus strain. Okay, we represent the y-axis as the amount of stress, and we represent the x-axis by the amount of strain. Okay, this is the epsilon, right? This is sigma, and the unit is in mega, right? 10 lessons to the power of 6, right? And yeah, you can use the this formula, the tensile strain during this region. It's called elastic behavior. Okay, and after that, you cannot use this formula to this one. Okay. Okay, let's take a look at this. We increase the force, right, and the stress is gonna be larger, right? It's gonna increase. Okay, it's gonna raise in once we increase the length, okay, we would also get the longer. Once we increase the force, okay, we are gonna have more length too, right? So the strain will increase, okay, and after a certain point, okay, the increase or the change of additional length, okay, doesn't linearly depend on the force or the strain at all, okay. We get here the curve, okay. It's not the linear anymore, okay. It's not linear anymore. And this one is this point, okay, the last point that gives you linear dependence to strain and strain is called elastic limit, okay. And that's the topic of this chapter, right? Elastic behavior. Beyond this limit, we're gonna have non-linear behavior of the solid. And yeah, if you still put more force onto this object, this solid, you're gonna break this object finally. And this point, okay, it's called breaking point, okay. And there will be two pieces from this experiment, okay. Both are gonna separate it from each other, and the object is completely deformed. All right, and that's the curve known as stress and strain, right? Yeah, you can see that the strain has no unit, okay, because it's the ratio of the same quantities, right? Length and length. There is no unit at all to the strain, right? And the increased length is not gonna be so much. You can see it's only a tiny amount, okay, 0.01. That is the maximum, okay. You cannot increase the length of metal or steel 1 meter, okay, from 1 meter, okay. The increased length of the steel will be very, very tiny. All right. Yeah, that's the relationship between strain and strain, or sigma and epsilon, right? This is epsilon, this is sigma, right? Let's go further. The tensile strength. This is the explanation of this. The explanation of this curve, right? And yeah, you can read it by your own. Okay, I have already explained it to you. Let's move to the table that the scientists have provided to us. It's taken from book number 1, right? They have provided the strength, right? What is the meaning of strength? Strength is the maximum strength, okay, that the object or the solid is gonna break down, okay. The object will have two pieces, okay. They will separate from each other if you put the force or the stress beyond this value, okay, these values. So the strength is the maximum value of the stress, okay, at this point, okay. If you project this point to the y axis, you're gonna have the so-called tensile strength, okay. In this experiment, okay, you stretch the object out, you get the tensile strength. But if you compress the object, okay, you're gonna have something which is called compressive, okay. It's compression, right? If you put the force in the opposite direction, it's called compression, compressive strength, okay. And yeah, let's talk about our setup, right? Our experiment, we stretch this cubic steel out, and for iron we would have something like 170 million omega newton per square meter, or megapascal, right? And steel is even more is even greater than iron. Aluminum has lower amounts of tensile strength. That's the max. Those are the maximum values to destroy this object, okay. to make them separated from each other. And the bone of our body is about 1.2. Okay, it's less strong than iron and steel and aluminum, right? Marble, right? Marble is not. It's not measured. If you just pull down, okay, it's gonna break down. Okay, and brick has also tensile strength. Okay, you can destroy brick by this value. And concrete, okay, if you, the first group is for mechanical engineer. Okay, mechanical engineering will use these values, but if you are interested in civil engineering, you are gonna deal with these values. Okay, brick and concrete. Okay, when you study the behavior of solid, right? These can be used in mechanical engineering and civil engineering. Okay, ทั้งวิศวะเครื่องกลแล้วก็วิศวะโยธานะครับใช้ค่านี้นะครับทั้งสองภาคทั้งสองภาคนี้นะครับคุ้นกับคำว่า stress strain แน่นอนนะครับเพราะว่าเขายุ่งในงานเขานะครับ and compressive strength is another aspect but we will not talk about that so much. Okay, the strength is the ultimate stress for various materials. And apart from these two terms, okay, strain sigma and strain epsilon, we would have the so-called Young modulus. Okay, I think this is the first person who deals with this ratio, right? Young modulus is the ratio between sigma and epsilon, right? The ratio between stress and strain, and y is taken from the first alphabet of the surname of this person, Young, right? And it's modulus. So as you know, if you move, it's actually come from epsilon by sigma by epsilon, right? Sigma by epsilon. All right, this one. You can see that the sigma has the unit of Newton per square meter, right? And epsilon has the unit of nothing, right? It's dimensionless, it's unitless. So we can infer that the Young modulus would have the same unit as that by the tensile stress sigma, right? It's Newton per square meter or Pascal, right? That's the thing. All right, and we would go further. The unit of the Young modulus is going to be Newton per square meter or Pascal. And if you substitute equation number 1 here and equation number 2, okay, we are talking about the longitudinal behavior of the solid, right? F by A to this position, which will appear here on the left, and delta L by L0 on the right, on the position of epsilon here, you would have delta L by L0, right? Yeah. And you will get this relation, or if you want to move it to the left-hand side, you would get epsilon as F and L0, right? And on the denominator, you would have A and delta L, right? That's another form of the Young modulus, right? A material. So what is the meaning in physical term? If you have a material that has larger value of Young modulus, it means that it's difficult, okay? It's difficult for you to stretch that material, okay? And or if you consider the compression, okay? For example, this one, steel for steel, we are more difficult to stretch steel than the iron because it has. Sorry. This is straight value. Let's take a look at this. Okay. The steel, right? Steel and aluminum, for example. It's difficult to stretch the steel out than the aluminum because it has larger value of Young's modulus than the aluminum, for example. Okay, 20 is greater than 7 in this aspect, right? Or compression too, right? Yeah, the figure 4 is the table of modulus, right? Young's modulus, which is what we consider here in this setup, right? We pull the cubic piece of metal, and we get the additional length delta L, and it has cross-sectional area A. Okay, that's the setup in Young's modulus. And shear modulus is another aspect. We will talk about that later. And the bulk modulus is the last one. Is the last experiment. Okay, is the last aspect for elastic behavior of solid in this chapter. Okay, we consider 3 experiments. Okay, 3 setups. The first one is longitudinal one here. Okay, and the second one will be the shearing experiment, and the last one is the compression. But in every direction, it's gonna call bulk. Okay, bulk compression. Okay, first we will talk about the first column here first, right? And they have provided this table for several substances. For example, copper, steel, tungsten, glass, quartz. Okay, you can see that glass might not have an exact value, okay, because it depends on the composite ratio of the glass. Okay, you have. Right. Okay. Let's take a look at the first experiment, first example. Okay, you have 3 formula, right? In physics, the formulas are quite important. Sigma is F by A, epsilon is delta L by L0, and we can use this formula only to this region, right? Elastic behavior, the linear behavior of straight and strain, and if you want to destroy that object, you have to consider this column, right? Tensile strength. And another formula is the Young modulus. It's Y is sigma per epsilon, right? And in a detailing form, you have this one, right? Y is L0 times F divided by A and delta L. Okay. A vertical steel beam in a building supports a load of 6 times 10 with the power of 4, right? You have an object here, right? This is the vertical steel beam, and there is an object, right, with the mass, and this mass is gonna pull the beam down, okay, downwards with the weight of F is 6 times 10 to negative not negative, positive 4 Newton, right? And I hope that everything is fine. ไม่รู้ว่าคุณได้ยินเสียงผมหรือเปล่าครับ Let me check ขอเช็คเสียงอีกรอบหนึ่งครับ right this right เสียงโอเคนะครับ เดี๋ยวขอเช็คอีกรอบนะครับ เดี๋ยวเวลาผ่าน load test 1 2 3เพราะทำไมไม่มีเสียงเลยครับอันเนี้ยนะพิมพ์มาครับ right ที่อันนี้ไม่รู้ว่ามีเสียงหรือเปล่าครับที่ OBS นะครับมีคนอยู่ OBS ประมาณ5คนนะแต่พิมพ์ชื่อมาเยอะมากครับ alright notice 1 2 3ไม่รู้มีเสียงหรือเปล่าครับแต่ว่าผมก็ไปต่อนะครับwhy สัญญาณไม่หลุดright again yes for this example for this problem we will have okay the most important thing in physics is that you have to write down the figure okay what is going on in this problem right the F is exerted on this object this is the vertical steel beam and if the length of ไม่รู้เสียงไปหรือเปล่านะผมไม่ได้ยินเสียงครับ alright มีใครส่งสัญญาณให้ผมได้ไหมว่าเสียงดีหรือไม่ดีนะครับ alright yeah the yes the question is the following if the length of the beam is 4 meter this is 4 meter right the original length of the beam so it's called L0 right and if the cross-sectional area of this beam is here A is equal to 8 times 10 raised to negative 3 square meter right the unit of the area okay and find the distance of the beam if the beam is compressed along its length out it's not tensile it's compression so I'm stupid it's not the case here we're gonna remove it right it's not like this okay it's compression so the force should be in this direction okay and F is yeah is the load right oh sorry is 6 times 10 with the power of 4 Newton right this is 2 4 and yeah find the distance the beam is compressed along its length right so this one should be L delta L 0 right delta L oh sorry delta L not be 0 what is that and the second question is what maximum load right the maximum load in newtons could the steel beam support before failing right so the maximum load should come from the from this figure okay if you take a look at this and if you put more stress onto that object the breaking point is this one okay that's the maximum value of stress and it's called strength right and in this setup in this experiment in this mechanism they use the compression right they consider compression we have to use these column right yeah and yeah, from equation number 4, which is the Young modulus expression, right? This one, if you wanna, we are gonna use the Young's modulus, right? We will use this table. Okay, so we will start from equation number 4. It's the formula of Young's modulus, right? If you wanna find delta L, okay, delta L here is unknown. Let's make it bigger. Delta L is unknown, and Y is available. We consider steel beam, right? Steel beam, so we have to take a look at this. It is 20 times 10 raised to 10, right? With the power of 10. Yeah. And that's Y, okay, for this setup. And L0 is the initial length, and they have provided the initial length by 4 meter. All right, 4 meter here. And you know L0, you know Y, and F is the force, right? External force. They have also provided here 6 times 10 raised to 4. And A is the cross-sectional area, which is this value, right? If you want to find delta L, you just move Y to the left-hand side, move L0 to the left-hand side. Y is going to appear as the denominator. L0 is going to appear as the numerator. So you will get FL0 here, all right? And AY as the denominator. And after that, you substitute all what you know, right? All quantities that you know that include F, the force, which is 10 times 10, 6 times 10 with the power 4, and L0 is the initial length, right, which is 4 meter, and A is the cross-sectional area, 8 times 10 raised to negative 3, right? 0.008, right? Square meter. You have to bring everything into SI unit, right? All these 4 quantities should be given in SI scale. Otherwise, you cannot be copied with the value provided in this table, because they have provided Young's modulus in SI unit, okay, which is Pascal. And yeah, you would have cross-sectional area, but everything is provided already in SI scale, right? The square meter here, right? And Y is Newton per square meter or Pascal here, right? And yeah, you can see that if you substitute it, F is 6 times 10 with the power 4, L0 is 4 meter, and A cross-sectional area is 8 times 10 raised to negative 3, right? It's very tiny. And the Young's modulus, I don't understand why they use this one. To Young's modulus, why? Two times 10 raised to 11. Why? I think this is wrong. Okay. อันนี้ผิดนะครับ อันนี้ผิดนะ ต้องเป็น 20 คูณ 10 กำลัง 10 นะครับ Okay. I think this is wrong. I'm gonna change it later. It's 20 times 10 raised to 10, because we consider this one, okay? Still Young's modulus, okay? We will change it. I will change it later and send it to you later. And after that, you can put it into this formula, and you will get something about 1.5 10 raised to negative 4 meter. ต้องขออภัยด้วยนะครับ อันนี้พิมพ์ผิดนะ น่าจะเป็น ต้องเป็นเลขนี้นะครับผมน่าจะก๊อปเลขผิดมาครับโอเค20 10 ยก 10นะครับอันนี้ไม่ใช่นะ alright it's the same thing I'm sorry it's the same thing actually ถูกแล้วนะครับไม่ได้ผิดขออภัยด้วยลืมนะครับ blur because if you put the 0 into this 10 with the power of 10 you're gonna have 10 times 2 times 10 with the power of 11 right and additional or one more power on here right it's already correct I'm sorry for that okay and steel beam will fail okay that's the value we get for the first question the second question is the maximum load right maximum F it's called strength tensile strength right oh no compressive strength we have to look at this column okay because we are talking about a compression here okay you have the force exerted into the object okay if you put the force out of the object it's gonna be tensile strength right but you put the force into the object it's called compressive strength and yeah the compressive strength is gonna be this right and yeah we would use this formula okay the tensile stress formula and you want to find F max right F max to this one right you would have F max which is tensile strength is gonna be sigma and A right yeah and with this one you just take a look at the table and look at the material you are considering you are dealing with steel right it should be 5 times 10 raised to number 8 right it's 500 megapascal and you put 500 megapascal here into this formula for sigma and เดี๋ยวเราจบกี่โมงนะครับผมต้องเลิกให้คุณกี่โมงM604 14 20 right 14:20 and I don't know for it's 4 p.m. right 4 p.m. 14 I have to finish for you right M604 okay F is sigma A right you put this value 5 times 10 raised to number 8 Pascal to the portion of sigma and you leave the value of the cross-sectional area that they provide here 8 times 10 raised to the power negative 3 and you would get the value of the maximum force right which is 4 meganewton or 4 million newton right and that's it for this example yeah let's move to the next type of elastic behavior of solid it's shearing experiment shearing deformation well another type of deformation occurs when an object is subjected to a force F parallel to one of its faces so let's take a look at this if you have a physics book okay this is a thicker book and yeah you have several on the order of 1,000 pages here and you can see that each page is not connected rigidly okay or firmly to each other they can move from each other but they stay on to each other by friction force right there will be many friction forces okay to each to several pages to each page in these books and if you leave your hand and you try to put the front cover of this book from left to right okay to the right direction and of course because there is a mass of this book exerted onto the surface of the table and there will be the friction according to the surface of the back cover of this book, there will be the opposite force, okay, the force in the opposite direction to this one. And yeah, we could not do that. And yes, yeah, the as we have two forces pointing in this direction and another one in the lower position, we have the force pointing in the opposite direction. Because several pages are not firmly connected to each other, they can move a little bit, right? According to the friction force among several pages. And yeah, the shape of this book is gonna be bent. Okay, and the shear stress displays the front cover of the book to the right relative the back cover, relatively to the back cover. All right, you can imagine this, right? If I write down, you have the initial state of the shape of the book like this, and after that, you're gonna have the shape. Okay, if you have the force in this direction, right, then the force, the reactive force, okay, the force of reaction in this direction, you're gonna have, you would end up with this shape for the book, right? And here is the front cover, here is the back cover. All right, and yeah, it's nothing more, right? And yes, yeah, with this setup, we would have, you can see it in more detail. Okay, this is the general diagram, okay, general picture, figure for that. This is more detailed diagram. Okay, you have area, okay, area on the table. It's not cross-sectional area, okay, but it's perpendicular to the force at all, okay. Unlike, it's not the same as this one, okay. In this setup, you have the cross-sectional area perpendicular to the force, but the area here is the area that touches the surface of the table, okay, area on this side. And at the starting point, we have the height of this object like this. And after that, when it is bent, okay, there is an additional or small value of variation. It's called delta x here, okay. It's the shape has changed from this one rectangle to this one parallelism. All right, and the shear stress displaces the top face of the block to the right relatively to the bottom. Okay, rectangular block. Okay, now we will talk again about three terms, right? Stress, strain, and modulus. In this setup, you pull out, or you stretch out the solid material. You have the so-called tensile stress, right? Tensile stress, sigma, and you have correspondingly tensile strain, right? Epsilon. But in this setup, you try to shear, right? So it's called sigma shear, okay? It's not simply sigma like this, okay? It's sigma with subscript shear, okay, which is used to differentiate it from this one, okay? It's the typical tensile stress. And also epsilon, okay, the strain, right, should also have the subscript denoted by shear, okay, because we are talking about this setup, this figure, this configuration. And yeah, it's again the same, F by A, okay, the same formula, but F is, okay, F is F, the same type of force, okay, but A is the face being sheared, Okay, it's the face lying down on top of on the surface of the table, and shear strain. Okay, it's quite similar to this one, but we don't talk about the additional length delta L at all. We would I'm not the person who defined this ratio. Okay, it's taken from the typical way that scientists have created, and it's called the additional deformation, which is in this figure the additional chain, the small chain in the side. Okay, it's delta x, and the original height. Okay, so we have the ratio between the additional length delta x and the height of this rectangle. All right. Okay, delta x is the horizontal distance the shear faces move, and h is the height of that object. Okay, now as in the tensile stress, we have Young's modulus, right? It's covered by Young, but for us in the shearing situation, we would have something similar to that. You can see that you have epsilon equal sigma by y, right? That's the Young's modulus definition. In this one, you would have the shear stress, right? S is sigma shear. Okay, sigma shear divided by epsilon shear. Okay, and after that, you put these result, right? F by A, and you substitute delta x by h onto this location, onto this position. You will get the shear stress, right? But in another form, if you just substitute, if you consider it like this, right? If you consider it like epsilon shear equal sigma shear equal epsilon shear times h. Okay, the small s represent shear modulus, right? This is shear modulus. Okay, s is shear modulus, and of that material. If you substitute sigma shear F by A to the left hand side, you substitute delta x by h to the right hand side, you would have here, right, this expression in equation 11. And let's take a look at this setup, right? The shearing deformation, a defensive lineman. Okay, this is the guy. I don't know whether you watch the American football or not. Yeah, but if you watch the American football, you would see, you would know several terms in this problem quite well, right? Let me conclude what is going on in this lecture, right? Check this one, right? And I sent it to you, right? Okay. Yeah. If you are familiar with the American football, I'm not sure มีใครเป็นดูอเมริกันฟุตบอลบ่อยๆไหมครับมีไหมเอ่ย if you watch it so often, you would know several terms in American football. Okay, in the United States, right? I think you may know better than me. They use the football to represent the American football, right? They use the soccer to refer to the football in the European continent or in Asia, right? They use these two words to differentiate from each other, right? And yeah. เดี๋ยวนะครับขออนุญาตส่งรูปที่ capture ให้นิดนึงครับ alright that's the way they differentiate the American football and soccer right มีใครดูเป็นไหมครับผมก็ดูไม่ค่อยเป็นนะไม่ค่อยรู้เรื่องกติกาเขานะครับ even you don't know อาจารย์ครับผมลืมพิมพ์ชื่อเข้ามาเลยครับนบครับนบนี่ครับคือผมทวนให้คุณนะครับโอเคป่ะว่าผมเห็นเท่านี้นะเดี๋ยวจะหาว่ามีการอ้ำอึ้งกันเหมือนที่ผ่านๆมานะว่าลืมมีต้องขอหลักฐานนะผมขี้เกียจไปถกเถียงอันนั้นกันอย่างนั้นนะนี่คือสิ่งที่ผมเห็นทางด้านฝ่ายผมนะครับ alright yeah ใครที่พลาดก็พิมพ์อะไรมาเลยนะครับจะได้ไม่มีปัญหากันนะครับ okay here is the story about American football. You have defensive lineman of mass capital M. Okay, this guy is big. Okay, this guy is big and he has M604 kg. Okay, and he moves. Okay, with VI. I stand for initial state, right? 4 meters per second. This is defensive lineman. All right. This is the story about the shear behavior, right? Shear behavior is somehow it is right. Shear behavior, okay. And yeah, you have another person. Okay, let's draw a complete scenario to this. It's better, right? You have first this person is called defensive lineman ไลน์แมนไม่ใช่ไลน์แมนคนที่ส่งอาหารเหมือนประเทศไทยนะครับโอเคไหมคนละความหมายกันนะโอเค defensive lineman M is 125 kilogram. Okay, this guy move with the speed VI initial state at 4 meters per second. All right, and there is another guy. Let's say it's drawn like this. This guy is smaller and he has a mass of only 85 kilogram, like that. Okay, and yeah, the question is the following: the lineman's helmet. Okay, that's the first stage. Okay, of course, this guy is going to hit this person, right? We call it the second situation. And because if you have ever watched the American football, this guy should a little bit bend his body like this. Right? Hand and his head, right? And he hit the upper leg of this guy, of these quarterbacks. Okay, this is known as stationary quarterback. Okay, he just stay idle. He has no movement or no speed at all, right? And yeah, he hit. Of course, you have 2 pieces of leg, right? And this one is called femur, right? The upper part of your leg is called femur, right? This guy hit the upper part of the leg of this person, the quarterback. Okay, the upper part of the leg of this quarterback, and yeah, but he didn't hit without anything. Okay, he wear the helmets for protection. Okay, for the sake of protection. Otherwise, he cannot play the American football next time. All right, his head is gonna be broken. Okay, the collision is linear inelastic, so there is no energy losses or momentum lost in this scenario. All right, and what is the speed at the final stage? Okay, the second stage of two athletes. Okay, of these two people immediately after contact, after collision. Okay, what do you think? When this guy move in this direction, and this guy just stay idle. Okay, he has no movement at all. Okay, these can be considered as a single object, right? And it's gonna be moved like this, right? With V final, the second state, right? Okay, combine these two people, these two athletes, into a single object, and you would have VF like that, right? And they asked us about the value of the speed, right? VF, what is that? What is the value of VF? And yeah, the way to solve this is the following. You use the P initial, right? P initial equal P final, right? Of course, initial state, in the initial state, we have only M times VI, right? Because M times 0, right? Because this guy at the first state has no movement, the speed is 0. He doesn't move at all, so the speed here is 0, okay? That's why we have 0 here. And in the final state, they combine, okay? They are combined into a single object like this, and the mass of this one is gonna be capital M plus small m, right? And there we have M plus M VF, right? And yeah, in order to find VF, right, we're gonna move this term to the left hand side, right? So therefore, we would end up with VF equal M VI times, oh no, not times 0, because it's not significant to us, right? We're gonna have M by M like this, okay? And you just substitute capital M, which is 125, right? And VI, which is they have said 4 meters per second, divided by the mass of the defensive lineman, which is the big person, 125, plus the quarterback mass, right? The small m is 85, right? So you put 85 into this, and you would get something about 2.381 meter per second. Okay, and that's all right for the first question. The second question is, if the collision lasts 0.1 second, estimate the average force exerted on the quarterback's femur. Okay, the upper part of the legs. ใช่ไหมใครคนไหนเรียนชีวะมาเฟมัวเนี่ยอ่านแปลว่าอะไรครับภาษาไทยใครตอบได้ไหมช่วยผมด้วย so if average is gonna be you would start from หมดเวลาแล้วนะแต่ว่าขออนุญาตจบตรงนี้นะครับif so that it's gonna be complete in a single lecture, right? If the other t นะครับแรงดนเนาะ and F average and equals the MV, right? m delta v. Okay, because the inelastic relation just transfer the momentum to the impulsive force, right? In yes, if you want to find the average force, you just have FAV equal m v. Yeah, in physics we have final state minus initial state, right? Sorry, it's capital M. Okay, it's capital M and divided by delta t, right? And you substitute everything 1 to 5 and VF, which is 2.381 minus 4, right? And divided by the time, which is 0.1 second, right? And yeah, you could see that the value will turn to be negative because this one is less than this one. And if you put it into the calculator, you would get negative 2023.8 Newton. Okay, you can see that the force turns to be negative. Okay, and it means that the velocity vector is in this way, right? This is the vector v. The force FAV will be pointed in the opposite direction to the velocity vector. Okay, FAV will be directed in the different direction, in the opposite direction to vector v, and that's the reason why we get negative value for the FAV, which is here, right? Okay, because we measure the FAV with respect to the same direction to the speed of the defensive lineman here, this guy. Okay, that's why we get negative value to that. Okay, in order to not disturb your time, okay, I'm gonna leave this lecture. If you have any question, just let me know because the time right now is 14:06, right? I'm gonna leave you to text list for the next subject in your studying calendar. We have no homework at all, and let's check whether another person who just say he didn't ใครไม่ได้พิมพ์อาจารย์ครับผมไม่ได้พิมพ์ลืมชื่อนบคือใครอ่ะชื่อจริงชื่ออะไรครับนบ Who is นบใครชื่อนบครับพิสุทธิ์ปองพลเหรอปองพลใช่ป่ะชื่อนบใครชื่อนบครับปองพลก็ถูกแล้วนี่ปองพลพิสุทธิ์คนแรกใช่ไหมครับอันนี้ของเราพิสุทธิ์คนแรกปองพลแล้วก็ปัญญะก็พิมพ์มาแล้วนี่ณภัทรคนแรกนะครับนบคือใครครับนบคือใครเห็นพิมพ์มากิตติพันธ์อยู่ที่ซูมช่องซูมคนเดียวนะนะครับมีอะไรครับเกิดการเข้าใจผิดอะไรไหมเพราะว่าตรงนี้มี4คนนะครับที่ซูยูทูบกิตติพันธ์1คนนะครับโอเคthen we have to leave this lectures see you later see you on is it possible to have the lecture tomorrow on Thursday because on Friday morning I have to attend the meeting of the department which is quite important ขออนุญาตเรียนแจ้งคุณว่าขอเรียนชดเชยวันพฤหัสนี้ก่อนนะครับเพื่อว่าวันศุกร์ผมติดธุระนะครับวันศุกร์ผมมีประชุมภาควิชานะครับขอเป็นตอนบ่ายนะครับยกเวลาเนี้ยนะครับเวลาวันพุธไปเป็นพฤหัสบ่ายนะครับขออนุญาตเรียนแจ้งคุณไว้นะเดี๋ยวพิมพ์บอกในไลน์กลุ่มอีกทีนะครับก็คุณสามารถออกได้เลยนะครับเดี๋ยวผมเปิดออนอยู่อย่างเงี้ยเพราะว่าให้605เข้ามาได้เลยนะไม่อยากเซตอัพใหม่เดี๋ยวเสียเวลาครับบ๊ายบายครับสวัสดีครับ อ๋ออาจารย์ครับผมลืมพิมพ์ชื่อตอนต้นค่ะนั่นแหละนบคือใครอ่ะคุณคือใครชัยสิทธิ์เหรอครับชัยสิทธิ์พิมพ์มาชัยสิทธิ์ชัยสิทธิ์พิมพ์มาครับพิมพ์ชื่อมาครับโอเค thank you ผมจะได้แจ้งคุณครูคุณเคยไหมครับเพราะว่ามันต้องลงหลักฐานฮะตอนปิดเทอมนะครับว่าตอนคุณได้เกรดไปเขาจะต้องลงบันทึกนะครับว่าคุณครูโคเขาคุณอะว่าใครขาดเรียนวันไหนช่วงไหนนะครับโอเคไหม all right what's going on yeah no and this one test 1 2 3 okay if not no test 1 2 3 hello test 1 2 3 test 1 2 3 test 1 2 3 low test 1 2 3 low test ไปเสียบอันนี้ all right this one. USB only once. Test. Test 1 2 3. Hello test. Test 1 2 3. Hello test 1 2 3. Test 1 2 3. Test 1 2 3. Hello test 1 2 3. Hello test. Just try. Let me see. Yeah, what is that? Let's yeah, it's 20. Dislocation. Yes. All right. Test 1 2 3 คิดว่าน่าจะได้นะครับเสียงน่าจะไปนะ Hello test 1 2 3เสียงต่อไป Alright แต่ว่าไม่เข้าใจว่าเป็นอะไรนี้เสียงไม่ไปนะครับ Alright okay we once everyone is already here in the classroom, we are gonna start our lecture right for the M605. Okay, let's change the name to this. This one is called M604. Right. 604. Okay, and okay, we have already there, and this one is M605, right? Okay, and let's open six. Oh no. This is heat and gas, right? Okay, the M605 term. Good morning, everybody. Good afternoon, not morning. Welcome you to SCI33206. Okay, not 5. It's wrong here. Yeah, Gone Natawin. Okay, I've already sent your name. Let's type your name. Let's look at chat. But the people in Zoom haven't written your name yet, right? It's up to you. Okay. Yeah. Welcome you to this semester. This is the SCI 33206. Okay, not 5. It's wrong here. I will change it later. Physics number 5 and semester 2 academic year to 2021, right? 2021. And we will talk about solid and solid and liquid. Right now, before that, I have to let you know that there are several stories in this semester, right? There are 3 chapters in this semester. The first chapter, which is the current chapter here, is solid and fluid. Okay, and the next chapter is atomic physics. Okay, you're gonna talk about Needle model and so on. Okay, and the next one is the last one is nuclear physics and particle physics. Okay, it's something more advanced. Okay, and the topic is not finished yet. Okay, something is going on. The research is still being developed. Okay, and yeah, let's get into this chapter, which is the second, the first chapter to this semester. Okay, this is the first chapter to the second semester in yeah, it's solid and liquid, and the content in this chapter is the following. We will talk about elastic behavior of solid. Okay, and yeah, you can say that the solid has a very strong internal force or cohesive force, right? Because their molecules are densely arranged, so they have a strong attractive force to each other, and we cannot destroy their bonding force easily, and what we could get is only some deformation. Okay, and yeah, that's the first topic. Okay, the first section in this chapter. In the second section, we will talk about surface tension. Okay, surface tension of mainly liquid. Okay, and the next term is viscosity. Okay, and the next one is fluid statics. Okay, the term fluid means 2 phases. Okay, before that we have to you get to know the you have heard the word the so-called there are three phases for any material, right? On in the universe, right? The first one is solid, right? Which is very strong. It has a very strong bonding force. Okay, their shape cannot be easily modified or changed. The next phase is liquid, right? And the third phase is gas state, right? And yeah, beyond these 3 phases, we still have ion, right? Ion, which is also called before ion we have plasma, right? And after plasma is gonna be เข้าสอนนักเรียนช่องทางไหนเดี๋ยวนะครับแป๊บนึงครับพิมพ์บอกคุณครูคุณนะครับ alright yeah คุณครูคุณถามนะครับว่าเขาอยู่ช่องไหนกันนะครับ okay the fifth state is the ion state, right? And that's in a very high that's the state with very high temperature. Okay, and yeah and also high energy. Fluid includes liquid and gas. Okay, fluid includes liquid and gas, and fluid in this section is only liquid. Okay, and mainly something about water. And fluid dynamics is the story about the movement of liquid, mainly liquid. In this chapter, we will talk about in fluid static when the water stay constant. We will talk about fluid pressure and buoyant force, right? The lifting force caused by the molecule of water or liquid, right? And what else? The fluid dynamics will be the ideal fluid continuity equation, Bernoulli's equation. Okay, and it is the flow or the movement of liquid inside a pipe, in the bending pipe, in the curvy pipe, and so on. Okay, let's start with the first section, elastic behavior of solid. Okay, this is only the section that deals with solid. The remaining 3 sections will talk about fluid. Okay, let's start with this one. We have the elastic property of solid will be discussed in two terms. Okay, 2 words. The first quantity is stress and strain. Okay, before that, I would like to mention to you that if you are interested inเดี๋ยวYouTube ด้วยครับจะบอกคุณครูคุณด้วยแล้วกันเดี๋ยวผมหาลิงก์ให้เขาก่อนand another one, right? นะครับคุณครูเขาถามมาครับให้ OBS yeah. Okay. Elastic behavior, right? Yeah. Before we get into the detail of these chapters, okay, I will give you a roadmap for you in the future. If I will give you only the story or the aspect of engineering, okay, because I didn't study faculty of science. My major is not in science. My major is not in medicine, biomedical, or something like that. I don't know. But if you are interested in mechanical engineering, okay, the 2 words, the 2 terms here, strain and strain, are quite important. Let me check whether anyone wanna join. Oh, sorry for that. ไม่เห็นนะครับขออภัยด้วย Anyone else? Sorry for that. Okay. If you are interested in mechanical engineering or civil engineering, okay, the terms stress and strain are the fundamental stuff to you. Okay, when you look at any material, you have to deal with this one. All right, and the next thing is the I'm not sure whether the sound is fine or not. ที่ซูมนะครับคนอยู่ที่ซูมได้ยินกันไหมครับได้ยินผมไหมเอ่ย พวกซูมได้ยินผมนะไม่ทราบเหมือนกันครับแล้วแต่คุณนะเพราะผมเช็ค604มันไม่ได้ยินนะโอเค alright the stress and strain are quite important for those who would like to study mechanical engineering and civil engineering. Okay, let's get into the details. Stress is the force per unit area. All right, and yeah, it's like pressure. Pressure is also the force per unit area, but stress is the same thing, but in the aspect of deformation. Okay, we would like to destroy this material or this object. Okay, because we want to observe the behavior or the strength of that solid before we build up something like the beam or the structure or the bridge or any building and so on. Okay, or any vehicle. Okay. All right. Yes. เดี๋ยวมีใครเปิดไมค์พูดอยู่ไหมครับเหมือนเสียงแทรกเข้ามาครับเฮนรี่นี่คือใครครับเฮนรี่ all right okay yeah there are three setups for studying the elastic behavior of solid. Okay, the first one is the tensile experiment. Okay, you pull out a beam of steel or metal, and the second one is that you consider the shear behavior. Okay, you try to tear apart two surfaces like this. Okay, you have the upper surface and you have the lower surface, and you put the force on top of the front cover of this book, and there is a friction in the opposite direction. Okay, friction force in the opposite direction to the above one, and this object is gonna change its shape a little bit like this. Okay, that's the second deformation, second kind of deformation for the solid. The third one is the compression, but compression in every aspect. It's called bulk deformation. Okay, for example, if you have a solid and you put it into the liquid, and if you leave it in a very deep position, the force of the water is going to compress that object in every direction and strongly. And of course, with the compression, the solid is going to have less volume. Okay, less volume means that you have volume deformation. Okay, the size of this object is going to be smaller. Okay, that's the third kind of deformation for the solid. Okay, we will see here three different kinds of deformation. The first one is the extension deformation, extending deformation, or the compressing deformation. All right, and you have a device that is fixed to the surface of the table, and you rotate it to keep this one. Okay, to keep this bar fixed to the surface of the table, and at the initial state, okay, at the beginning state, the length of this bar is L0, okay, whether centimeter or meter, any kind of unit. Okay, and you try to pull out this bar. Okay, it's a kind of metal, it's in solid form, and of course it's going to be stretched, right? The length of this bar is going to be longer, and after a certain time, you will see that the shape of this bar is increased by this amount. But we just only observe the additional length, and the additional length is denoted by delta L. Okay, whether it's centimeter or meter doesn't matter. Yeah, and that's the tensile deformation. Okay, yeah. So let's get back to these two terms. Actually, there are three terms. Okay, the last one is gonna be considered later. The first term, stress, is the ratio between force per unit. It's like pressure. The tensile setup, tensile deformation will be something about the force here, the magnitude of the force here, divided by the cross-sectional area of the object that you pull it out. Okay, that's the stress, and the stress is denoted by this formula. Okay, sigma is F by A. Okay, and F by A. Yeah, let's take a look at F. F is the force here. Okay, and A is the cross-sectional area. As you know, the force has the unit of Newton, right? As usual in physics, right? And A, the cross-sectional area, of course, in the SI system we have square meter, right? And yeah, ห้อง605แล้วพิมพ์มาประมาณนี้นะมีกรนะคนแรกนะครับหมายเลข1นะณัฐวินภวัฒน์ปานธรนะครับภวิทย์กฎชาวงศ์วัฒน์นะครับนนทกรนะครับแล้วก็ช่องที่ซูมไม่มีใครพิมพ์มานะครับแล้วก็ผมขอเช็คที่ตรงนี้นะครับ anything else ชัดที่วารินนะครับธนกรปาฏิหาริย์นะครับ alright ปาฏิหาริย์วาริน from ปาฏิหาริย์ to วารินทรีนุภาพนะปาฏิหาริย์ until วาริน alright and 605 right oh no this one okay and yeah, let's get into the detail of yeah, the force has the unit of Newton, and the cross-sectional area has the unit of meter square, right? So the unit of stress, okay, the tensile stress, actually, if we say it completely, it's the tensile stress. The tensile stress has the unit finally as Newton, which is the unit of force, by square meter, the unit of area here, right? And sometimes we would say Pascal or PA, Pascal, and yeah, that's it for the tensile stress, right? Let me remind you that what I have seen is the following. Hold on. This group, right? Okay. Yeah. What else? Yeah, it has the same unit as pressure. With this experiment, there is another term, right? As you know, strain, right? Strain is another quantity that is going to be considered in this topic. Strain is defined as the additional length and the initial length L0. Okay, delta L by L0 is the ratio. Is another ratio that is considered in this topic, and this ratio is called tensile strain. Okay, they use the letter epsilon. Okay, letter epsilon. Why epsilon? Because epsilon looks like the letter E in English, and letter E would mean the error. Okay, error because you put a force, and the shape of this solid bar has changed from the length of L0 to delta L. So they just assume that the cross-sectional area is the same. So the volume change will be the ratio between delta L by L0. Okay, that's the same thing. And this is called strain. Okay, simply speaking, strain. If we make more analysis to the strain, you can see that strain at the numerator we have delta L in, for example, in SI system we have meter, right? Meter as the unit of delta L, and the initial length of this bar is L0, which is also in meter, and you can see that epsilon should have no unit at all, because meter by meter is gonna cancel each other. Okay, and it's only one, right? So epsilon, or strain, or tensile strain for the full name, has no unit, or it's called dimensionless quantity. Okay, it's unit less quantity. Okay, that's for the tensile deformation. Anything else? Let's อาจารย์ครับไม่รับผมเข้าขออภัยด้วยครับ Unsigned 3 people. All right. Yeah. Let's get into the complete picture of what we make here in this experiment. You put a force onto the solid bar, the rectangle, the cubic bar here. At the beginning, okay, you got to know the straight and strain already, right? Straight is the force per cross-sectional area, right? And strain is the ratio relative distance, the additional length by the initial length, right? Yeah. The scientists or the physicists have tabulated or studied the behavior of the solid and plot the relation between straight and strain like this. Okay, they increase the stress on the y-axis and see what's going on the x-axis as strain. And then ผมไม่มั่นใจนะครับว่าเสียงไปหรือเปล่าครับครูจอยเสียงไปไหมเอ่ยall right. Yeah. The linear increase could happen at this state. Okay. Okay. The detail of this one is the following. The tensile stress is linearly proportional to the tensile strain in a certain range. This length, okay, it's called elastic behavior of solid. Okay, which is the topic of this section, right? And it is possible to exceed the elastic limit of a substance by applying a sufficiently great stress. Okay, if you put more value of force or stress, okay, stress and force are relatively dependent on each other, right? If you put more force, you will have also more stress. And now the relationship between strain and strain is not going to be linear anymore. Okay, it's no longer linear. It's a curve linear. It's a curve dependence here. Curve dependence. Okay, it's not linear dependence. And at the elastic limit, the stress strain curve departs from a straight line. Okay, actually it should go further like this, right, in the straight line direction, straight line route, but it departs from the straight line. It's a curved line like this, and at the elastic limit, it departs from the straight line. A material subjected to a straight beyond this limit ordinarily does not return to its original length. Okay, if you put more force or stress more and more, and if you leave the force in this figure, okay, when it's stretched beyond this limit, and if you take the force out, okay, you let the force out of this setup, the piece of this solid is not gonna be back as the same shape before, right? They would not return to the same shape because we are beyond the elastic limit, okay, and does not return to its original length when the external force is removed, okay. As the stress is increased further, it surpasses the ultimate strength, okay. If you still put more force onto this object, you put more and more force onto this object, you will see that you will pass the breaking point, and the single piece of metal is going to be separated into two pieces, okay. They will be broken down, okay. And surpass the ultimate stress, which is called ultimate strength. Well, the greatest stress the substance can withstand without breaking is shown for several materials in figure 3. So here the tensile strength for several material is provided in this table. For iron, you have 1.7 times 10 less to 8, okay, Newton per square meter. We have also the value for steel, aluminum, bone, okay, the solid piece inside our body, right, the bone, and we don't have it for marble and brick, okay. This is the stuff for mechanical engineering, okay. We are talking about tensile strength, right, but you may observe that they have also provided compressive strength, okay. The difference between tensile strength and compressive strength is the following. Tensile strength is something about you let the force get out of the piece of solid. But for compressive strength, you turn the direction of the force into this object, okay? It means the opposite direction of the force is exerted on this material, okay? That's the compression to the steel or to the object, all right? And what else? Nothing more. This is the part for mechanical engineering, okay? They have to consider iron, steel, aluminum, or even bone, right? But bone would be something for biomedical engineering. But for civil engineering, they are gonna look at these material, these two materials, brick, concrete, right? It's on the order of million. Right? The iron, the metal like iron, steel, or aluminum have more tensile strength than the material in civil engineering like brick and concrete. All right. Let's get further to, you have got to know two terms already, right? The tensile stress, the tensile strain. Okay, the tensile strain has unit as pressure. The tensile strain has no unit. Okay, and the third term is the modulus. Okay, the modulus. let's get into the modulus. Modulus is actually defined as they use the y, the letter y, because let's say we are talking about the Young modulus. Tensile modulus is known as Young's modulus because this is the surname of the person who consider this stuff first. Okay, this story, and Young modulus is denoted by the letter y. Is the ratio between stress and a strain. Okay, and it's actually sigma per epsilon, right? And you would see that sigma has the unit of Newton per square meter of Pascal, and epsilon, which is just ทำไว้ในซูมไม่มีเสียงนะครับผมถามทุกคนอยู่เขาก็ไม่บอกผมครับ alright เสียงไปหรือยังครับเสียงไปแล้วนะครับผมน่าจะกด device ผิดพลาดครับมันก็เลยไม่ไปนะครับโอเคครับจะได้ไม่ต้องใส่หูฟังครับผมก็ไม่รู้ครับตั้งแต่605มาเขาก็ไม่พูดว่าเขาได้ยินกันหรือเปล่าครับไม่ใช่ตั้งแต่604ตั้งแต่604มาผมถามว่าเสียงได้ยินไหมผมว่าเขาเข้ามาออนแล้วเขาก็คงทำอะไรอย่างอื่นแน่นอนครับผมก็ถาม605ตั้งแต่เริ่มต้นแล้วตั้งแต่ครูจอยไม่เข้าว่าเสียงไปหรือไม่เขาก็เฉยๆของเขาผมก็ไม่รู้ว่าจะว่ายังไงครูเข้าไปดูใน YouTube ได้ยินนะคะแต่ว่าในเนี้ยไม่ได้ยินในซูมเอาละครับไม่รู้เกิดความผิดพลาดทางเทคนิคอะไรยังไงนะครับผมถามเขาเรื่อยๆอยู่แต่ก็ไม่มีใครตอบผมว่าเสียงไปไหมนะครับก็แล้วเด็กๆทำไมเข้า9คนเองนะคะเนี่ยไม่ใช่เลยจะมีบางส่วนครับที่อยู่ที่ YouTube แต่ว่ามีก็คือเข้ามาพิมพ์ชื่อกันเฉยๆครับเดี๋ยวผมส่งรูปให้คุณครูจอยดูก็ผมเน้นที่เขาพิมพ์ชื่อครับคือเขาไม่ได้เขาเข้ามาพิมพ์ชื่อเฉยๆแล้วเขาก็ไม่น่าออนเพราะว่าผมสามารถเช็คได้ว่าใครกำลังดู YouTube ดูไม่ใช่จำนวนคนที่ดู YouTube อยู่ครับมันสามารถเช็คได้ครับแล้วก็ผมอันนี้มองไม่เห็นว่าใครกำลังดูอยู่แต่ว่าที่ OBS เนี่ยมี2คนที่กำลังดูอยู่นะครับเดี๋ยวผมcapture หน้าจอให้คุณครูจอยดูก็ได้ครับว่าใครเขาดูใครเขาเข้ามาพิมพ์ชื่อบ้างนะผมไม่พูดว่าใครกำลังดูอยู่นะเพราะว่ามันเช็คไม่ได้นะครับก็คือที่ซูมมันจะได้ 720p ครับแต่ว่าที่ YouTube มันจะได้หน้าจอที่ละเอียดกว่าผมก็เลยเปิดโอกาสให้เขาดูในที่ YouTube ได้ด้วยมัน1080ครับแล้วก็เฟรมเรทมัน60ด้วยครับมันเยอะกว่า30แล้วก็ใน YouTube มันสามารถเช็คได้ใช่ไหมครับมันก็พอดูได้ครับว่าใครกำลังดูอยู่ครับว่าจำนวนคนที่กำลังดูอยู่เดี๋ยวนะครับผมเข้ามาที่อันนี้ก่อนนะครับ alright chat นี่นะครับตอนนี้มีนะครับก็มีตั้งแต่ปาฏิหาริย์นะครับปาฏิหาริย์จนถึงวาลินเนี่ยครับโอเคค่ะครับถ้าดร.เช็คได้ก็ไม่มีปัญหาครับก็ทำอย่างนี้มาตั้งแต่เทอมที่แล้วครับกลางเทอมที่แล้วค่อนต้นของเทอมที่แล้วครับก็โอเคค่ะถ้าดร.เช็คได้ก็โอเคครับก็ใช้วิธีนี้เช็คกันอยู่ครับเพราะว่ามานั่งขานชื่อเดี๋ยวมันเหมือนตอนต้นเทอมครับมันเสียเวลามากครับแล้วเราไม่ได้ ไม่ได้เรียนกันเลยอะไรเงี้ยครับก็มันเสียเวลาเช็คชื่อไปเฉยๆครับเพราะว่าผู้ปกครองเขาก็บ่นมาครับผมก็เลยต้องเลือกใช้วิธีเนี้ยกลับไปเหมือนเดิมเหมือนครับ เพื่อไม่ให้เสียเวลาครับได้ครับได้ครับ
ครูแค่สงสัยว่าเอ๊ะทำไมถึงไม่ได้ยินเสียงแต่พอไปเปิดใน YouTube ได้ยิน
ครับมันเซตอัพคนละแบบกันมั้งครับ อันนั้นมันจะละเอียดกว่าครับ อันนั้นนะครับ
ค่ะ
ครับ
เชิญดร.ถอดต่อเลย
ครับโอเคthe young modulus right yeah young modulus is the ratio between stress and strain right it's sigma per epsilon right and you know that epsilon has no unit right it's dimensionless quantity and sigma is Newton per square meter so the young modulus would follow the same unit as the stress right which is sigma it's also Newton per square meter or Pascal, simply speaking, okay, Pascal is PA, right? It's the same unit as pressure, right? And if you write it in another form, strain is the product between Young's modulus and the strain, right? And if you substitute the strain formula into the left hand side of this equation and you substitute the strain delta L by L0 to the right hand side of this equation you're gonna end up with this relation, right? And yeah, it depends on the problem would like to know, okay, which quantity the problem would like to know. For example, if they want to know the additional length, okay, we have to move L0 to the left hand side as the numerator. We have to move y, the modulus value, to the left hand side as the denominator. Okay, it depends on the question in each problem. Okay, yeah, the Young's modulus can be provided for both tense stretching deformation and compressing deformation. And what is the physical meaning of the Young modulus? If the object has more value of Young's modulus, it means that that object we will be able to stretch or compress that object more difficultly, okay, than the object that has lower value of Young's modulus. Okay, the more the Young's modulus you have, the more difficulty you try to change the shape of that object. Okay, that's the conclusion or the result that you can infer from the Young's modulus. Okay, well, we consider only the tensile or stretching deformation or compressing deformation. There are also two additional kinds of deformation. The second one is the shear deformation. The third one is the bulk deformation or the volume compressing deformation. Okay, we will talk about that later. But the first one is Young's modulus, right? Yeah, they have provided this value based on this stretching experiment for several materials, for aluminum, bone, brass, copper, steel, tungsten, glass, quartz, and so on, right? But we don't have Young modulus for water because you cannot keep water and try to pull it out, right? Or mercury, okay? We don't have Young's modulus for the liquid, okay? We are talking about elastic behavior of solid only. Well, let's go further. Let's do consider practice ourselves with the first example. A vertical steel beam in a building supports a load of 6 times 10 raised to 4. Let's write down, set up 2Ds, and Yes. Okay, we have steel beam like this. Okay, and it's held on the ground, and there is some object, okay, that put the force onto this beam by 6 times 10 with the power of 4 Newton. Okay, that's the force exerted on this beam, and the length of the initial beam is 4 meter. They say 4 meters, so we follow that. 4 meter, and here 4 meter, and its cross-sectional area is 8 times. Okay, I'm not sure whether it's circle or any shape of this beam, because they didn't say rectangular or what. So A in this case is 8 times 10 raised to negative 3 meter square. Okay, and the question is, find the distance the beam is compressed along its axis. So once you leave the beam like this, okay, and finally the beam is gonna be shorter, okay, because it is compressed. Okay, you would see that the length here should be lower than that, right? It's called L0 minus delta L, okay, because there is the compressing difference of the length here. It's delta L, right? And yeah, they want to know this value delta L. What is that? Okay, in yeah, that's the first question. The second question is maximum load in newtons could the steel beam support before failing. Okay, yeah, it's not stretching setup, it's not stretching deformation, it's compressing or compressive deformation. So all the values related to this experiment or deformation should be something about compressive strength, right? And yeah, they say that the material is made of steel, so we have to take a look at steel. And yeah, compressive strength is this value. And what about the Young modulus, right? Actually, we should the formula that is related to delta L is only a strain, right, which is delta L by L0, right? But we don't know. They didn't provide the value of strain at all. We are gonna move to the formula of Young's modulus, which is this one, number 4 here, F by A delta L L0 Y. But the question, the first question to this problem is delta L, right? We have to move the remaining parameters or variables to the left hand side. This one, L0 to the left, Y to the left. So we are gonna end up with delta L. Delta L will be F L0 divided by A and Y. Okay, and F is the force, right? The force is 6 times 10 power 4, and L0 is 4 meter. A, the cross-sectional area is 8 times 10 raised to negative 3. And the last one is Y, the Young modulus. So we are going to use the Young modulus for steel by on this table on the first column. Okay, just look at steel, right? Take a look at steel. We would get this value, okay, which is 20 times 10 raised to negative 10. All right, and you leave it into the calculator, you would end up with 1.5. Oh no, it's not approximation. It's simply equality. Okay, it's 1.5 10 raised to negative 4 meter. Okay, 0.15 millimeter, simply speaking. Okay, and that's delta L for the first question. Okay, distance beam, that beam is compressed along its length. The next one is the maximum load in newtons could the steel beam support before failing. Okay, when we talk about the beam that fails, we are gonna deal with these breaking point. Okay, and the breaking point is denoted by tensile strength or compressive strength, right? But this one is the experiment or the deformation about compression, right? The deformation by compression. So which column should we apply, should we use? We have to take a look at the compressive strength on the second column, because this is the compression of the force. The force is directed into the object, right? It's not directed out of the object. So in that case, we would use tensile strength. But the force is pointed to the object. So it's compressive strength here. And take a look at steel. We would get this value 5 times 10 times 10 with the power of 8. Okay. Tell us to number 8 in what formula should we apply to this one? Yeah, it should be straight, right? We're gonna use the straight formula again. Straight, and it's epsilon is F by F max, right? It's F max by A, because this is the situation that we break the material, and this is the maximum force actually. So the maximum force, the maximum load will be F max equals epsilon and A, and epsilon here will be the compressive strength, okay, Newton per square meter here, and steel is 5 times 10 raised to 8, right? And the cross-sectional area is only 8 times 10 raised to negative 3, right? And yeah, you know that this is 40, right? 40, 5 and 8, and with the power of 5, you reduce the 0 to the right hand side is the power of 6, right? It's gonna be 4 times 10 raised to the power to the 6, and it's Newton per. Oh, so it's simply Newton. I'm sorry for that. That's the force. Oh. Okay. It's, oh no. It's Newton, right? Yeah, and that's for this example. Okay. We have already completed 2 answers to this problem. Next, we go to the second kind of deformation, right? Second kind of deformation. Another type of deformation occurs when an object is subjected to a force F parallel to one of its face. Okay, you put the force in parallel to that object. Okay, and in the opposite face, or in the opposite side of this surface, it is held fixed by a second force. Okay, we consider, for example, here the book, right? A very thick book. It has several pages on the order of 1,000 or several thousands of pages, and we have the front cover and the rear cover. Okay, and we leave the rear cover onto the surface of the table, and we leave the force in the same direction as the front cover. And of course, the book has its own mass or the weight, right? There will be a friction, and the friction is gonna point in the opposite way as as our force direction. And yeah, of course, if you have the force direction like this is your force, and the friction force is pointed in the opposite way. The shape of this rectangle is gonna be deformed a little bit by this one. Okay, and the book will have a different shape from the original state. Of course, the book has the height here, and the change in this shape is delta x. Okay, and there is the cross-sectional area of the book. Of course, as mentioned before, in the tensile deformation, in the stretching deformation, we have three words, right? The first word is the stretch sigma, right? The tensile stretch sigma, and we have also the tensile strain epsilon, right? Delta L by L0. But this one, we don't have delta L. We don't have L0 at all. Okay, the shear stress is gonna be the same as the tensile stress. Okay, it's F per A, the force per unit area, and the epsilon, which is the ratio between deformation and the original object, right? It is defined here as the difference distance delta x. Okay, it is defined as delta x. Okay, delta x here divided by the height, the original height of this object. So we end up with sigma, epsilon shear is delta x by h, and A is the face being sheared. Okay, and A is this one. Okay, this area. Okay, the shear stress is related. Okay, we have already tensile stress, tensile stress, this one, tensile strain, and of course we have the Young's modulus, which is the ratio between stress and strain, tensile stress and tensile strain. For shear deformation, we would have also the shear stress and the relationship between shear stress and shear strain, and that one is called S. Okay, they use S as shear modulus. Shear modulus is the same thing. Okay, it's sigma shear divided by epsilon shear. Okay, and yeah, if you put the ratio of sigma shear F by A and epsilon shear, you would end up with F above and H above and A lower in delta X here. Okay, that's the formula of shear modulus. Oh, sorry, with US too. All right, and if you can also express it in another form by sigma shear equals epsilon shear time S, okay, when S is shear modulus, okay. S is the shear modulus of that material. Okay, let's take a look at the first example about shear deformation. When you have where is that? When you have a book like this, okay. No, but it's not the book, okay. It's the story about American football, okay. Have you ever watched American football, right? I think most of you have ever watched it, the American football, right? In in American football, we have, I don't know, I'm not a fan of American football. In the United States, they use football to represent American football, okay. For us, we would say American football, and they use the word soccer to represent the typical football for European continent or in Asia. We say football as football, right? But in United States, they say soccer, right? Because they want to differentiate it from the American football. They use the word football for American football. And here we have the problem related to American football. Defensive lineman, okay? It's a person here. That's the first state. Okay, the first state, we have defensive lineman, okay? This guy has the mass of 125 kilogram, okay, and you have another person right there. This guy is of this mass 125 kilogram and makes a flying tackle. So makes a flying tackle is a special word for American football. If you have ever watched American football, you would realize that it means this guy is moving, okay, with velocity vi. The subscript I stand for initial, okay, initial or the beginning state. Initial velocity or initial speed at 4 meter per second. Okay, 4 meter per second. You can convert it to kilometer per hour later. Okay, it's now 12 or 20 kilometer per hour. Okay, and there is another person who is called quarterback, right? Quarterback is another guy standing here, and this guy has no movement, okay. His velocity at the beginning state, at the first state, is 0, okay. This guy just stand up and has no movement at all right. And after that, okay, this guy has the mass of 85 kilogram, okay. This guy is smaller, okay, is lighter than the defensive lineman, okay. And I don't understand why they call defensive lineman, because this would be offensive, right? Because this guy is moving to another person. But anyway, that's the word from the problem in book number 1. I'm not fan of American football. I don't know so much about the story in the stuff in the American football. All right, this guy just stay idle. He has no movement at all. And in the second state, this guy, of course, the center, the lineman, the defensive lineman should wear the helmet, right? You would be able to imagine the defensive lineman, right? lineman, American football, right? With football too, WL, right? Just take a look. Okay, this guy. Okay, you could see that the player in American football, they wear the helmet like this here. Okay, they wear the helmet, and another one more thing is that he has to wear something to protect his chest here, okay, or even leg. All right, yeah, because they wear the helmet, and they're gonna tackle, right? They're gonna hit this person, the center back, and after that, this guy will hit, because he wear the helmet, right? His shape is gonna be like this, right? I may not draw it in a good scale, right? And this guy will touch the upper part of the legs of the center back person. Okay, this guy. Oh, I'm still cannot draw it properly. Right. All right. This the defensive lineman will hit the upper part of the leg of this quarterback, and it's called femur. Okay, and yeah, they say that the collision is linear inelastic. It means the momentum at the first state and the second state are the same. Okay, remain constant. And yeah, the first question is, what is the VF, the final speed of the two athletes immediately after contact? When this guy hits the upper leg of this person, the center back, of course, this guy just stand up without any speed, and this guy comes with 4 meters per second. What do you expect at the final state? These two people will move together, right? The inelastic or linear collision means that both will move together. Okay, if they say elastic, it means this guy would get back to the opposite direction, but they will move together with this speed, the new speed, and it's called VF. And the question is, what is the value of VF in this scenario? Okay, the first state, the initial state, and the final state. Okay, so in elastic collision means that we have P, which is momentum, right? P initial or P beginning, P initial equals P final. Okay, the second state. And of course, if you take a look at the first state, the initial state, there will be only this guy who moves, right? And it's M times VI, right? M times VI plus small m, who didn't move at all. So the speed of the second person is going to be 0. Okay, if you want to see the whole system momentum, okay, the momentum in the whole system, we can have something like this, right? P initial, and after that, this guy could these two people could be considered as a single object. Okay, they're gonna be considered as a single object, and they will move together with the speed VF. So the mass in this scenario will be M plus the capital M plus a small m times VF, right? The final velocity, right? Which is what we would like to know. And because our target is to get the value of VF, we are going to move the unrelated stuff, which is capital M plus a small m to the left hand side. So therefore, the final velocity will be VF, right, which is equal to m vi divided by capital M plus small m, right? Now you're gonna leave the value of all these three terms, right? The capital M is the mass of the this guy, the defensive lineman. The small m is the mass of the quarterback, right? And the initial velocity is 4 meters per second, right? So right now we have already values for that. It's 125 and 4 meters per second and 125 plus 85, right? And if you take a look at this, if you put this ratio into the calculator, you're gonna have the final velocity, which is approximately 2.381. Of course, the velocity is meter per second. All right, that's the value for VF. Okay, that's the value for VF. But the second question is if the collision lasts for 0.1 second, estimate the average force exerted on the quarterback's femur, right? Because he just hit the upper part of his leg, right? There will be force, right? There will be force. And yeah, the way to do is the following. You have to recall the formula from your former years by F, I don't know, impulse force or something, impulsive force, F delta T equals P, okay, and P is mv, right? P m delta v, sorry. F delta T is delta P, right? And this one is delta mv, right? But the mass of the whole thing doesn't change, right? And the mass is the mass of the defensive lineman. Okay, it's mass of defensive lineman, but a defensive lineman doesn't have mass change, so he has only the velocity change. So this one is gonna be finally F delta T equals capital M and delta V, right? And you know that delta V is VF, right? In physics, when we talk about the difference from two states, we would say VF final minus initial, right? VI, right? And yeah, what they want to know is the F average. So this is called FAV, F average. Okay, because the force should be high. Okay, and it could increase, and after that it will decrease and remain zero, right? So we would talk about the average value, which is FAV. So because our target is FAV, we are going to move delta T to the right hand side, right? So therefore we would end up with FAV equal M and VF minus VI. Please note that we use the capital M because this guy, the defensive lineman with the mass capital M, is only the single object that moves, right? This guy doesn't move, so we don't take into account, we don't consider the small m at all. And yeah, we have m delta v like that, and we move delta t to the right hand side. It's gonna appear here delta t, and what they say is that delta t is right here. They say 0.1 second, right? 0.1. So let's substitute everything into this ratio. Mass is 1 to 5, right? And final velocity is what we just got here, 2.381. This one, okay? 2.381. 2.381 minus 4, right? The initial velocity. Okay, initial velocity in this direction, and VF is also in this direction. So divided by 0.1 second, right? 0.1 second, and you leave it into the calculator, you would get the ratio of you get the result, right, as negative 2023.8 Newton. Okay, 2023.8 Newton. And you may ask me, what is the reason why? What could we get the meaning of the negative side here? What does that mean? Well, we have to notice that we start from every quantity from the left to the right, right? The direction of movement is from left to the right side, right? It means that, but for us, when once we get the negative value of FAV, it means the FAV is the force that take place in this direction. Okay, FAV is from left to left. Okay, from right side to the left side, because the ball is gonna hit the head or the helmet of the defensive lineman. This guy is in the opposite direction. Okay, FAV will be pointed in this way. Okay, and that's the meaning of negative value for FAV. So let's get into the next question to this one, right? Okay, there is another question. They say that if the cross-sectional area of the quarterback's femur is equal to 5 times 10 to negative 4 square meter, calculate the shear stress exerted on the bone in this collision. Okay, assume that the femur, or the upper part of the leg of this quarterback, has the area. Okay, the area at this location is 5 times 10 to negative 4 square meter. So what is the sigma shear in this scenario? Okay, what is sigma shear? So in order to deliver the answer to this problem, we have to get back to the shear formula, which is here, right? Shear formula is F by A. Okay, F by A. So if we want to find shear stress, we just simply use this formula, right? Sigma shear. Sigma shear is actually, it should be absolute value, right, of FAB, because we don't consider negative minus sign at all. The state is only a scalar quantity, right? And A, right? FAB is 2000, right? The absolute value 2023.8 divided by the cross-sectional area, which is what is that? I just write. It's 5 times 10 with the power of negative 4, right? And you put it into the calculator, you will get the result as 4.05 times 10 with the power of 6. Okay, let's just do the positive 6. You can write down in either Pascal or Newton per square meter. Okay, both are valid. Okay, both are acceptable, but I prefer you to use the shorter one. Okay, Pascal is the more general term. Okay, and that's it for this problem. Okay, we would คุณครูจอยไม่ทราบว่าอยู่หรือเปล่านะครับคือผมต้องเทอมนี้ต้องเบรก20 นาทีให้นักเรียนอยู่เช่นเดิมใช่ไหมครับเพราะว่า
ใช่ใช่ค่ะแต่ว่าดรก็แล้วแต่ตกลงกับเด็กเลยค่ะว่าจะเบรกระหว่างคาบหรือว่าจะท้ายคาบหมายถึงว่าคาบของเรามันเป็น2คาบติดใช่ไหมคะ
ครับ
ก็ไปปล่อยเร็วได้ค่ะ
ผมก็เนี่ยครับก็คือกำหนดการคือเลิก16นะครับผมก็คงเลิกแค่15:40เพราะว่า20 นาทีเป็นเบรกให้เขาครับ
อย่างนั้นละค่ะ
ครับ
ของเราเป็นคาบคู่อะค่ะไม่สามารถที่จะระหว่างครึ่งกลางๆได้
ครับงั้นก็คงต้องจบเนี้ยมันจะได้พอๆกับ604ครับ
ก็ปล่อย20 นาที
โอเคก็ใครยังไม่ได้พิมพ์ชื่อนะครับขอย้ำอีกรอบนะครับถ้าใครที่ฟังอยู่นะโปรดพิมพ์ชื่อมานะครับเดี๋ยวมีปัญหาเรื่องคะแนนเข้าเรียนกันอีกนะเพราะมันก็สำคัญนะครับโอเค we don't have homework กันหรอกคุณครูจอยครับคือวันศุกร์ครับคือผมติดประชุมอะครับตอนเช้าอะครับแล้วอยากนักเรียนพรุ่งนี้ได้ไหมครับวันพฤหัสครับเขาติดกันหรือเปล่าเลย
ม.5 ม.6 เขาจะรอดอค่ะเขามีรอดอพรุ่งนี้โรงเรียนก็ไม่ได้สอนกันค่ะที่โรงเรียน
แต่ผมเคยนัดชดเชยเขานักเรียนติดไหมครับตอบผมหน่อยได้ไหมก็คือห้ามชดเชยเลยใช่ไหมครับงั้นผมก็ต้องวันศุกร์ครับโอเคงั้นผมไม่ชดเชยก็ได้ครับงั้นเรียนวันศุกร์ตอนเช้าแล้วผมก็ประชุมไปพร้อมๆกันก็ได้ครับโอเคครับก็ today is gonna be over right now okay we have to quit the lecture if you have any question just let me know ก็วันนี้ก็คงจบการเรียนไว้เพียงติดรอดอบวกฉีดวัคซีนครับพวิทย์บอกโอเคงั้นก็ไม่มีชดเชยครับเขาพิมพ์มาใน YouTube นะครับก็ขอบคุณมากครับพวิทย์ครับที่แจ้งนะผมก็เรียนวันศุกร์ธรรมดาครับเดี๋ยวผมประชุมใส่หูฟังไปพร้อมกันด้วยเลยครับก็ทำไงได้ครับโอเคครับก็see you on Friday morning สวัสดีครับบ๊ายบายครับ
สวัสดีค่ะ
สวัสดีครับwhich that's the จานยังไม่ได้รับผมครับตายตาย the last present is which right okay that's fine in Thailand Benden and yes